In a world that walks the line, there's a rare few who think outside the box together for the crew. To break the equations, not bound to any rule. Exposing to the world the universe's own view. It takes the talent of the craftsman, it takes the mind of the fool, to make the vision realize energy and matter in a duel. To a break, to a duel. The old man, bills was running through his head. Cheryl probably got it hiding under his bed. Penny up to any, making power for days. Don't listen to a word that the straight dope says. Mike building batteries that power a ship. Victor comes and talking math, that's the water spiral dip. Shawn chucking plasma bolts a mile long. Sheila on the video making tones from the throngs. Bernie breaking matter, they said it couldn't be done. And to all the people in the chat, I know you're having fun. So it's time to spend your Saturday with the doping old man Bill.
What's up, everybody? Oh man, we got this thing messed up today.
Hello,
there
hello.
We go.
This would be hard.
What's going on, guys? Everybody, I'm Nathan, and you guys know that. I'm Old Man Builds. Shawn and Joe, what's up, guys?
Hey, good to be here. Missed you guys.
Happy day after Thanksgiving.
Yes, yes. Great to see you guys in the chat. Thank you for the kind remarks. Awesome, awesome.
Right on. Yeah, give me just a second, man. Everybody showed up, man. They're looking forward to when you're here, Shawn. So
appreciate it.
Put up the comments, man. Every time I turn on StreamYard, they keep changing something, put 50 million more buttons on there again. Driving me absolutely insane. It's like, dude, just freaking leave it alone. I don't care what your new feature is. Oh.
Yeah, it's tough sometimes.
All right, Shawn, you got a presentation, man, and then we're going to talk about it, man, because these things are really cool that you're doing, man, and Joe and I are totally in on it, man.
Oh, awesome. Yeah. All in.
I appreciate it, guys. So, ready to get started, Nathan?
Yeah, let's do it.
Awesome. So, if you guys can see on the screen a giant eyeball, that means we can start. Let's see here. All right. Oh, perfect. Okay, so I always like to start off with my dad's art if I have a piece of his. So he drew this for me about a week ago, and he wanted me to share it. I asked him if I could share with you guys. So yeah, my dad's an artist, been an artist for like 50 years. Okay, I'm going to come actually back to this. I got my slides a little bit out of order. But what I'm going to be sharing with you guys is what I'm doing with the RAV and my latest experiments with the RAV, things I've learned. And so this is one of the RAV setups that I have, but it's going to be really similar or almost the same every time. So you'll notice the red wire here in the background, and it comes up to this alligator clip. And then you have this little point here. That's the anode. And then the bottom here, whatever I connect to the bottom here is the cathode. And this is connected to a high voltage power supply. It runs between 5,000 volts and 30,000 volts. I usually use the full 30,000 volts. And it's a precipitator power supply. And it's built to where it's made for sparking and arcing. So you can have this thing sparking all day, and this little power supply will run all day. So 30,000 volts, and this is going to be 5 milliamps is the maximum. So even though it's a scary voltage, because of the amperage, you still have to be careful, but it's not, you know, you're dead before you hit the ground. So the bottom we have the cathode, and the top we have the anode. And this is a setup where I have a wire coming off of the flat cathode, very thin wire, and then at the top of it, I have a little melted piece of metal. And this is going to be explained later, but I kind of wanted to talk to you about the environment. So it's always the same. I got the anode on top, cathode on the bottom, and then how I do the cathode here at the bottom depends on the experiment. So I use paper clips or just pieces of wire. If you get spring wire, you can order spring wire from Spring Steel, actually it's called. You can get it off of Amazon for a pretty low price, and they're great all around for for experiments. So this is probably spring wire, not a paper clip, but you'll see that I just bend it into a triangle and then another little triangle on top. And then if you'll see, there is a piece of red clay, because you know RAVs love to run on clay, especially red clay. And so this setup is what I'm going to be explaining here pretty soon. I used to call this the angel RAV. So it's kind of maybe the slang for it because it flies kind of over the bench. And I'll show you what it looks like later, but I guess the nickname is the Angel RAV. Now, it's the same setup, but I'm turning on now the 30,000 volts. And what you're noticing here is that it starts to form a spinning plasma, which we call the RAV. And if you'll notice here under the clay, there's all of these sort of jagged kind of structures here. In the past, I'd call it the fractal snow because I didn't know what it was. But after some research and getting some good information from Joe and Nathan, what we're discovering here is that the plasma is making crystals. And we're going to see these crystals, and it's going to be pretty awesome because when you see plasma self-organize and spin, you think that that's enough. That's pretty incredible. But not only does this spinning ball of plasma self-organize, self-confine, but it also now it actually creates crystals. In a book that I'm going to share with you in a little bit, but they've actually proven in the lab that plasma can take one molecule and then build out a material. And at first they thought it was just dust until they found out it was an actual, it's called the dusty complex plasma. It's actually crystals. And there's something unique about these crystals. I haven't finished the book yet, but basically these crystals could store information and kind of like a hard drive. So we'll see more of these, but I wanted to share this with you. The RAV is off. It's not on the bench, so it's kind of floating here with this little wire. So that's why I call it the Angel RAV. Now, I'm going to be trying different materials. I'm going to be trying different conditions. Here again, we have the Angel RAV setup, little piece of clay, and we're running now 30,000 volts, and I'm trying different materials. For some reason, I can't see this clearly, but I'm pretty sure it's clay. But if it's not clay, it's going to be lava rock. Those have been the two things I've been using. Okay, so it's clay. There is a lot going on in here, but I want to get through my videos and slides. I just can't wait for Nathan and Joe to take these things apart and answer our questions. So, because there's a lot going on here. All I see really is just the RAV spinning on top of this little piece of clay and hanging off the bench a few inches. This is the same RAV condition, but it's in the middle of a ring magnet. And the anode on top here is not a point, but the anode on top here is a sphere now. This sphere is about 1 centimeter in diameter. So the RAV is not a bad size. It's almost a sphere in diameter. But what I'm trying to do is just to see how it operates in a magnetic field. And I'm not really seeing that much effect in this setup. But in other setups, I've seen that these ring magnets can either aid in building the RAV or work against the creation of a RAV. But I'm not seeing it here in this Angel RAV setup. This is another similar setup without the ball at the end. And so I think I like this video so you can kind of see the environment that I'm doing it in. Again, it's super simple. You just put a drop of water on the clay. You have it suspended here from about 1 inch or 2 from the cathode plate on the bottom. And then the anode's always about 2-3 millimeters away. Sometimes it could be up to 5 millimeters away. What I've discovered is if you get in that sweet spot and it's actually a little closer than you think, that's when you make the biggest RAVs. I think I took this photo here of one of the RAVs just getting so large. This exceeded the size of the anode. So this was probably maybe a half, 3/4 of an inch in diameter. Now this is a silly thing that I'm doing here, but I was trying to figure out how when you read about E-B drift, E is for electric field, B is for the magnetic field. It talks about how it causes things to move. So I took this paper plate, the pink here is the electric field, and it's just pointing this way. It's moving away from me in this with this arrow. But then perpendicular to that, you have the magnetic field moving. And so what I'm doing here is I'm trying to just add both forces. And if I add both forces asymmetrically, it turns every time. Now, I actually did this with the ball, and it's the same thing. So when you ask, hey, what's spinning the RAV? This is kind of an oversimplification, but it works. And basically, it's just that when you have the electric field and the magnetic field perpendicular to each other, and they're pushing, one of them is not going to push with the equal strength of the other, and therefore you're going to have spin. And so I had to figure this out. It's backed by a lot of physics. I know Joe and Nathan are going to have some brilliant explanation for this, but that's the simplistic one. That's helped me a lot to understand why it's spinning or how it's spinning. So why do I call it an angel RAV? Well, this little angel here, she's holding on to the anode and she doesn't want to go. It's one of the reasons why I call them angel RAV. I know it's corny. Let's see here. There'll be a little bit of repetition here, so I'll be moving through, but pretty much I wanted to kind of share with you different phenomenon. Let's see here. Yeah, I'm not seeing anything much different. Very similar to what they always look like. It's interesting that the light is so bright, it's heating up the anode. And so I put a little water here, and that way then when I run the experiment, it's connected. So I'm using wire as kind of a connector. So if you saw it get red hot over on the bottom there, now it's fine. So with high voltage, I just squirt a little water here and there because it's very safe to have a wet surface when you're working with high voltage. I'm joking. Do not play with water and high voltage like I'm doing here. So wherever it gets hot, wherever it's not connected well, I just do a few drops of water and then I'm safe. All right. Here's my setup, lava rocks. There's the water that I use for the cathode connection. I didn't have a connector, so that worked. But this is my work area. This is where I do all my recording and my work at. I'm looking for some crystals with holes in them so I can start creating some crystal RAVs. But right now, let's see, we've seen these. Let's see. One of the things that's interesting to me too are these beams of light. I don't change the camera angle at all. It's basically, I mean, you think I'm holding it now, but I'm kind of just zooming in and out on the tripod. But I don't move the camera to the sides or, I don't play with it. So when I see these streaks, there's something going on with the light. And that might be a good question for Joe and Nathan. There's something going on with the light because why is it all of a sudden refracting? And my theory is that these are the poles, the magnetic poles. So the other one side is the North Pole, the other side is the South Pole, and it's a magnetic setup kind of similar to our Earth. That's my theory. Let's see another close up. Let's see. And I got a 4K camera, so we'll see some really interesting shots of the 4K camera as well. Yeah, just another experiment. Here you get to really see how nothing's on it. I call this the self-nucleating RAV. because if you turn on full power, it'll melt this wire, and then you turn off the power quickly, it'll leave like a little ball at the end of it, like you just saw. And then once I turn off the power and it cools down, this little bead here, then when I restart it, I can create a massive RAV on it. This wire is 0.16 in thickness, and yet I'm putting in about 75 watts. Now, you could Google it, 0.16 millimeter wire and 75 watts. There's no way. The wire should just incinerate. But because the RAV is so efficient in this setting, it's somehow either bringing in some kind of sonic cooling, which that was Brent Jarvis's good idea. But there's something going on where it's, as it spins, it's cooling. Otherwise, this little thin wire would just disintegrate. And I play with this. I increase the voltage more and more, the current more and more, to see how big I can get the RAV on this super, super tiny thin wire. And it's pretty incredible. This is a pretty incredible discovery. Not only can you research the RAV in a more 360-degree way, but you're finding out that the RAV is actually feeding on the air and the moisture in the air, because there's no clay, there's no water, and usually clay and water are the ingredients for RAV, but you're not getting any of that. And so there must be something, moisture in the air. It's somehow consuming the air. Now, in that little piece of slag, there are little caverns in it. When I was first sharing this with Nathan, before I even brought the picture up of this little cavernous piece of slag, he had predicted that it had canals in it in order to move or facilitate the RAV. And I thought, how did you know? And so then I brought a microscopic picture of them, and they in fact do have the caverns. And I'll share those microscopic pictures with you in a little bit. Oh, and by the way, the wire that I used is that spring steel wire. I haven't tried other wires. I do know in other experiments, if I switch away from the spring steel wire, I get different effects, or I get undesired effects. But it's up to you guys what you want to try. Let's see here. I have a diagram. No, this is not the right one. Let's see here. Okay, so I'm looking for a RAV super material where I can build bigger RAVs. And so I'm experimenting, and this material here is lava rock and a powdered graphite. This little disc here is graphite. And what graphite does is it seems to sort of amplify the RAV effects. So what happens is that the electricity is here. You see it going in from the anode inside the cathode here. I'm sorry, the graphite disc cylinder, and it's created a massive RAV at the edge of it. So I was playing with that because I think graphite has some kind of effect that increases the size of the RAV. This is another photo I took, and so what you're seeing here, this is a centimeter diameter anode, and you're almost breaking that centimeter size, which is big for a RAV, because this is very, very compressed, highly compressed electrons. So this is a high energy, I guess, I think they call it a pseudo black body. That I think that's what they call it. It's just, so it's pretty intense. So when you get a little bit bigger, you're actually exponentially more energy. Now I like to try different clays. I like to try different rocky materials. The reason why I wanted to share this, let's see here. Let's see. I wanted to show. For some reason, I see trees through this entire through this entire video. I see beautiful trees. You know, I like the artistic part. This is a clay that didn't work out too well, but I wanted to kind of show you how beautiful this thing is. Let's see, I think I passed it. Where It's almost like you want to hang it up on your wall. There we go. This is the one I liked, the blue tree of life there in the middle. I don't know if you guys can see it. So there's just so much beauty in plasma, so much beauty. I think this is the super material that I'm working on. You're getting a massively bright RAV. It's just refracting. My camera is just like, what are you doing? This is lava rock. So this is more of the porous lava rock. I'll give a warning here. The porous lava rock can explode, and I've had that happen. It's not fun. So if I'm working with the porous lava rock, I'll have like a piece of plexiglass as a kind of a shield, a blast shield. But I've only had it once, and maybe it was a fluke. But the other lava rocks that I work with, they're a lot safer. They don't have those issues. So again, we have the slag at the tip, super thin wire. We're going to create an awesome RAV. We're going to create a powerful RAV that is too big for this little thin piece of wire. And I think this is even a thinner piece of wire. And just trying to push the limits here. Try to see if I can get this RAV to a place where maybe it doesn't need any constraints. I'm working on another model where I'm going to eliminate the whole bottom. That's actually going to be levitating from the bottom. That's my next generation that I'm working on in the lab. I'm pretty close. I have all the parts. Nathan gave me the good idea of having a spinning magnet under the RAV. So I'm going to try that as well. But I'm going to work with some levitation, some repulsion technique to try to see if I can eliminate the space at the bottom here and have the RAV float in space. Because I want these to be lightning balls. I want them to be able to be free and go through walls. And I think that's hence why I'm using thin wire and getting it off my bench. How can I get this plasma ball in the air? That's just a goal I have with the RAV. Again, just showing you how I've run this for 10 minutes at a time. The little wire is great. It doesn't melt. Now, if I don't balance it right, then it disintegrates really fast. So this is a balancing act. This is, once I set it, then it's fine. But if you're here, I just got out of balance, and watch it. It just swallows the wire and spits it out. So this is kind of an example of when it's not balanced. I kind of wanted to show you this. This is a failure versus when it's a success. And so this is what physics tells you it should do. But when it stays on the tip and can go indefinitely, there's something that's broken physics there, I think, but maybe I could be wrong. Now, I bought these tiny clay pots, and I thought that the way the plasma came in was really fascinating. And I'm also working on increasing the voltage in the current. And this is one of the fascinating things about RAVs. You'd think that you would get a bigger RAV if you put in more voltage, but that's not true. You think you might get a bigger RAV if you increase the current. That's not true. What's interesting about the RAV is it needs a balance. And it seems that 30,000 volts and 5 milliamps is its sweet spot. And so it's good to know that. Otherwise, you're going to pull your hair out thinking, oh, I'm going to make a bigger RAV. So this is the cylinder of graphite. And I like how, again, electricity passes through it. And look at that. It amplifies the RAV effect. And it looks like it's amplifying it. And in every case, graphite either builds bigger RAVs or it builds multiple RAVs. But there's some connection here with graphite and like the acceleration of plasma, and then the RAV loves it. The RAV just starts forming anywhere as long as it's around the graphite. It just boom. There's a lava rock you can see with the lights on. I'm gonna do a lot of my experiments with the lights on so you guys can see, and you guys can, if you want, you can replicate some of my experiments. And so this is just a lava rock, plain old, lava rock that you would find on the ground in someone's landscaping or something. And I put a little water on the bottom, way too much water, because lava rocks actually don't need water. Lava rocks have oxygen in them. They have a set of minerals in them where I found out later the only reason water is good for lava rock is to accelerate the creation of the RAV. But for lava rock, heat is what creates the RAV. Heat is the thing that gets the RAV. Oh, I dropped my camera. Sorry about that. It's heat. If you can heat up the lava rock, then you don't need water. Now, this is the book that I mentioned earlier. Ian had recommended this book to me maybe 100 times, and and so I finally broke down and bought it. And I was reading the first chapter, and I couldn't believe the similarities of what these scientists have found about plasma and how they relate to our RAV. Now, this guy's a fringe scientist, but all his friends are Nobel Prize in physics and chemistry. So they're mainstream. He's a mainstream physicist or a science writer. But this book is pretty incredible. I don't agree with his conclusions, where he believes that plasma are really sentient beings. They're a different kind of life form. But a lot of the plasma physics in this book is made for the regular person. There's no math. It's just, so the way it's written is really nice, and you can learn a lot about plasma. But as I was reading here, first couple pages, here it says in 1961 that plasma may exist within living organisms. That was interesting. And then in 1962, until then, they were thought to be ice grains. It was really made of carbon. This entirely was a revolutionary idea, important to this book, because as we've seen, complex dusty plasma contain such dust, was accepted by the astronomical community 5 years later. I'm having a hard time reading. And so what we're seeing here, as the scientists build on their knowledge, they're finding out more and more things about how plasma might be some kind of life system. Here in 1963, it says that this may sound very obscure and technical, but we will see later that it was fundamental to the advance of plasma physics, including the regard to plasma's capacity for bringing some of the weirder quantum phenomena into the macro world. And so this guy is talking about bringing in the quantum into the micro into the macro. In 1986, this Japanese scientist predicted that plasma could exist as crystals. He called them Coulomb crystals, named after Charles Augustin de Coulomb, a pioneer of the studies of electricity. He said these crystals could be formed by dust particles in a plasma. This is one of the key discoveries concerning the subject of this book, because crystals play a vital role in storing information in ways necessary for the evolution of intelligence and communication. As we will see later, it would be 7 years before this Japanese scientist prediction was proved to be correct. And so in 1989, the scientist here in IBM said that plasma actually manufactures dust. But the interesting thing is that the dust was found inside fusion reactors and other sources, not dirt or contamination as it had been assumed, but was created by plasma itself. So what we're seeing with plasma here is that plasma is transmutating the surrounding air into a dust molecule. Now think about that. It's actually plasma's changing one state of matter into a different state of matter. And so here in his dramatic experiment discovery, Selwyn was able to show by laser light scattering that starting from a single molecules, dust grew naturally from the nanometer sizes up to the micrometer sizes within the plasma. This changed the whole face of science of plasma research. Until then, plasma dust was viewed as dirt. And so I thought I would just add these points here, because when we're going to look at the crystalline structures that I'm seeing the RAV create, this kind of gives an interesting backdrop, I guess, the scientific support about these crystals being made. And so this book's going to go into plasma crystals, and then how crystals are really interior structures for living a different type of life form. And it's a really good, interesting book. And so I thought I would share that with you guys to kind of give you a backdrop. Now, when we start seeing these fractal patterns, we start seeing this. It almost looks like coral, or it looks like a snowflake, or all the different crystalline structures that you see. Now, what I'm trying to do is the impossible. I want electricity to run through a ceramic, a very high resistant ceramic. And so what I do is I add a little water into the ceramic tube. The ceramic tube, I mean, would need like 1,000,000 volts to break through it when it's cold. But if I can get the electricity to go through it with a little water, and I put it in the right spot, and then what you'll see here now is now I'm going to start superheating this ceramic tube to the point where it'll become so hot, it will give electrons so freely that it'll actually be like a copper wire. And so, and I'll explain why I'm doing that later, but this is just a trick I learned, I came up with. And so basically, if you want to heat something up to white hot, that's like a ceramic or clay, just add a little water, put some voltage through it, and this thing will get so hot. And this is important because I want to create RAVs, but I want an insulator. I don't want any wire at all. And so you'll notice here that just even within a minute, that thing is getting pretty hot. In fact, my infrared camera can't even read. My infrared can read about 850 degrees. Yeah, this is probably like 1,000, 2,000 degrees. It's pretty hot. What's cool about it now is it's basically now a copper wire, so I can use it that way in this hot state. Let's see here. So now I'm putting things on top of the ceramic tube. This is a pyramid of clay that I cut out, and you can see that it's actually created 2 RAVs in this picture. That was kind of a fun screenshot. We'll go back to that pyramid later. Now, what you're seeing here is the same ceramic tube, and if you guys are interested in the ceramic tube, it's called alumina ceramic. Alumina, like aluminum. It's spelled like aluminum without the N at the end. So it's alumina ceramic, and it's very expensive. But if you get these little tiny thin tubes, they're not expensive. On eBay, you can get a pack of them for probably $10. So they're not very big. But what's interesting is they're perfectly clean and brand new when I get them. And I run a little plasma through them, and all of a sudden, what is this? What are those things? Get them in sight here. It's building crystalline-like structures, just like the book said. It's just, and the thing is, you need the right environment to do this. It needs to be very specific. I had to learn this a little bit the hard way, but the environment has to be very specific, and then all of a sudden you'll see growing these crystals. And so we'll talk a little bit more about it, but what's going on here is I put a little piece of clay on the top, jammed it kind of in the hole. I put a little water, and as I begin to heat it up, and the RAV started to form on top, we're getting these guys that grow. These sway and move in currents that you can't see, and then they'll break away. And they'll just sort of go out, and when they break away, they go like 1,000,000 miles an hour because you barely can see them. This was the different pyramid that I put on. This is a pyramid made out of graphite, pure graphite, and I put it on that cylinder with my little, my little setup here. The spring steel looking like a paper clip here. The bottom plate here is a cathode. The top is the anode. Same power supply, and it's getting a really nice RAV up there. I'm really trying to figure out the graphite. And some of the things I've learned in these experiments is that it creates different kinds of environments where inside this tube that it draws the water inside, and then it will charge the water. And then when the water gets charged, it'll come out in these vapors. And this was pointed out, I forget, I think Nathan pointed this out, but it occurs basically when the water hits the right temperature, you'll start seeing some effect. And it's so fascinating. Okay, so here you can see this is like a piece of copper wire now, because the electricity just hits the middle of a ceramic tube. We know electricity can't go through a ceramic tube, right? So I've accomplished that goal because I need that for these experiments. So we're seeing here now, when I put the clay here in the tube, I then get those these here, but these little snowflakes. I wish the arrow didn't come in, but you can see those little snowflakes there forming at the bottom. They will not form unless I have clay in the mix, or if I have lava rock. The tube alone, the ceramic tube alone, will not create any of these fractal coral shaped structures, these crystalline structures. They will not create it unless you have some kind of substrate material and you're creating RAVs. So that's just important to know, because if you're going to go and try to replicate my experiments and you're not getting these crystalline structures, it's because you don't have clay. I jam specks of clay inside the tube opening here, and then I add a little water and boom, I start growing these crystals. This is my 4K camera, so it's really crisp, but sorry for that it's far away. But you can notice that they build up and then they fly like super fast, and they sway. There we go. See, one took off to the left. One of the things too, if you watch this video closely, there's actually things also coming in. So there's just sort of coming in and leaving. I'm not used to my new camera, so I don't know what I'm doing. It's blurry. So I don't really figure it out it's too late. But these let's see here. Yeah, these structures here, I mean, it's incredible. And the way they move, it's almost like coral under the sea in ocean currents. So pretty fascinating. All right. Let's see here. So we got a RAV. So we have some sort of substrate, and you can see now that on the right side of the tube, you can see those little crystalline formations there on the right. And so it's not forming everywhere, but it's forming there on the right. And that's the formula. Here we have a clearer picture. I think this is the same tube, but I zoomed it back a bit. But yes, again, on the right, you can see it's starting to grow those tendrils that we're now getting familiar with. So we have now this, it's almost like a built of ash, or maybe the particles that the plasma is creating, that kind of plasma dust. But we're gonna have two more types of fractals that the RAV creates. So this is one that the RAV creates, and I don't really have a name yet for these guys. So we're still in that early phase, in our discovery phase. This is kind of showing you the clay, the red clay pyramid that I had soaked in water. And you can see here that the tube is, the ceramic tube is turning hot, so it's conducting. And then once it turns into a copper wire, super hot, now RAVs can form on the pyramid. So I'm kind of kickstarting things, turning the power on, turning the power off. And what's going to happen is I'm going to create a reaction here where RAVs are going to start forming on the pyramid. And so that was the goal. There we go. Boom. Now we have a spinning ball plasma on the pyramid too. There's two of them. And it's suspended by the electrons traveling through a ceramic tube, because now the ceramic tube is, it's like a copper wire, but it still has some resistance. And again, the reason why I like using the tube instead of the wire, the ceramic instead of metal, is because I want that high resistance. I don't want all of my power going down the wire into the cathode. So having the ceramic tube there is kind of like a big resistor. It lets electricity flow through, but it allows the power to really stay on top. And you can see how good size the RAVs are getting. You're asking why the pyramid shape. I was just trying different shapes. This is the same setup, except for instead of a clay pyramid, this pyramid is made out of solid graphite. Not too exciting things happened with this, but I'm still testing and playing with graphite. I just thought this would be interesting to share. Same setup, anode on top. The bottom plate is the cathode, 30,000 volts, and electricity goes right through the top of the graphite, right down this white hot ceramic tube. It touches this metal bottom here, which is the cathode. I drilled a hole in lava rock. We're going to start seeing some lava rock, which is, I think lava rock is a super RAV material. And so here, it's interesting that it almost looks like the rock that you would see if there's an earthquake and a volcano came out. I thought that was kind of cool to see. But what I'm going to start doing is building some RAVs on some lava rock, and kind of wanted to show you how I'm going to get started. See here, which one is this? So lava rock, this is the lava rock that I picked up that's used in gas grills for like decorative purposes. It's used in fire pits or fireplaces. So it's tumbled, and it's a lot more beefier. Not much going on there. It's a lot beefier of a rock. So we'll show you how how cool it is in a little bit. So here, I'm trying to get this tube to heat up so it can become conductive. But what's happening here is I'm getting this really interesting scatter effect. And I thought it was just worth sharing with you guys. It's just beautiful. Is that because I cannot get the ceramic tube to the right temperature, it just starts turning into this blue spray, and it's almost like a spaceship is flying through like a particle field, and it's going like warp 2, warp 5. But yeah, I thought it was cool. It looked like blue rain to me. But these are the states you have to kind of fiddle with if you want to get these ceramics to become conductors. And once you get them to become conductors, it opens up the door for a lot more experiments. Let's see, I jammed a little bit of clay in here, so this might show us the fractal type material, or this just might be a 4K that I wanted you guys to kind of see it really super clear. You can see the water kind of boiling. First it boils out, then it boils back in. You can always tell when the RAV forms. It has a very distinct refraction signature where it's just very distinct. It's almost like, the sun has its really powerful rays. That's basically what the RAV does when it's in full motion. Right now, we're just not really getting the RAV as we just got earlier. But you can see, let's see, you can really see, like, there's the RAV right there. I want to point this out. This RAV is in the cylinder, sorry, the tube here. And my goal is to try to get RAVs to be formed inside the tube, because if I fill up the tube with water and I can get RAVs to work in water, that would be a step up also in my experiment. So I want to get RAVs moving in water, and I'm going to show you. I figured actually out how to do it just today, so I'll show you that picture. I think this just describes again what we're doing. Top is the anode, bottom is the cathode. Got a little piece of clay, and then we got the what the heck. We got the stuff growing under the clay. It's another picture of it. You could just, it's so incredible. I mean, what do you do with that? It's beautiful. And now we have some science that says it's real and it's significant. So I just can't wait until I think the ideas are going to come from you guys. I think the ideas are going to come from Joe and Nathan about what we can do with these crystals. Let's see, we've seen that before. We've seen that one. Here's the one where you can actually see them dangle and kind of they undulate like in some field. You can see them break apart. You can see them build. Still learning my camera, so I got too close. But look at that. That's pretty incredible. Pretty incredible. Guys, I'm sorry I can't see your comments, but I will take a look at them when I'm done the presentation. I want to thank you guys for your patience. I got quite a few slides here, but I appreciate you guys. Okay, this one's a piece of salt. Right there's a grain of salt. And it has, when plasma hits salt, it has that distinct yellow color. And but watch the salt. Watch the rim around it. Watch the edges around it. It's beginning to grow crystals. It's so incredible. It's not as fast as you'd think, but as you look at it, it starts growing. Let's see if we can move it here. Notice the edges now. Look at the edges. They're crystalline. So this speck of salt is actually being surrounded by these plasma crystals, and they're growing because you can start seeing the edges here. None of this was there when we started it. You saw that little white piece of salt, but now look at it. And I believe if had I run it longer, it would probably have some significant crystal effects. Now you're wondering why I didn't run it longer so it can turn completely into this plasma crystal. Well, honestly, I don't see half of my experiments. I just put the phone up, hit record, and I run my experiments. I don't really go through them. As you can see, I dropped my camera or something. And then later I look at them. So some of these, like that one, I didn't really see until I put the presentation together for you guys. So that's a really good one. I thought it was so good that I thought I would do another short clip of it and watch these crystals grow. At first, these gave me the heebie-jeebies because it's what's going on here. I mean, look at that. If you just, what is going on? Yeah, the salt is being transmutated into these structures. I annotated here. If you guys want to take a screenshot, I annotated my setup. So, you know, the cathode pan, my little bent piece of steel, put water down a little tube, and then I have my, that's my cathode, sorry, on the bottom, and the anodes on top. And I have my little Chinese, has all Chinese writing on it. There's no English. 30,000 kilovolt power supply. You can get it on Amazon for under $100. But it's worth it because I use it all the time for hours. Now I bought these little thin glass tubes that they use in labs. I put a little water in it, and I'm gonna get some different reactions now because I'm not working with ceramic anymore. I'm working with glass. Glass is going to show you some different phenomenon, and we're going to kind of close on this presentation on glass. And I appreciate you guys hanging in there with me. So as you notice, the water became conductive, and then now the water inside the tube is ionized, and it's now working as a conductor. And on the top, because this is a borosilicate glass or Pyrex, it melts really nicely. So what's happening is you're getting a glass RAV. It's spinning plasma. It has the same effects as a RAV. Now it's not a RAV there, but it's a RAV when you see it have all the beams of light. So not every spark and arc is a RAV. It has to be a spinning ball of plasma. There you go. It's almost there. And it's using the melted glass in this for this. Now this is part of me trying to get RAVs working inside water. And so you don't see really any RAVs inside this water, maybe except for on top, which is outside. But if you look at the bottom, there's one trying to form. It's getting bright, but that's not quite a RAV. That's just plasma. And so you buy these little capillaries glass on Amazon. You get like 100 of them for $10, 15 bucks, and just pull them out and put drops of water in them and light them up. So this is a tube. I should pause it here because this is something special. Let's see here. So this is a tube. It's a light bulb, an ultraviolet light bulb that's used in hand sanitizer machines. I don't know if you saw during COVID, they were selling these machines where you put your hand in or you'll put jewelry in it, and the ultraviolet light would come in and kill all the germs. Well, nobody wants them anymore. So if you go to the thrift store, you can get them for like $1. So I always buy them because they have these really cool ultraviolet tubes. Now I broke off the ends of this one because it actually had a gas inside of it, but I want it as a tube of glass. My guess is this is quartz. Now, when you see the red parts there inside the tube, that's powdered red clay, and it's wet. So you're kind of seeing some water, wet clay, and now I'm going to run 30,000 volts through it. One thing that's kind of a bummer about this, and maybe Nathan can do this later, but this turns into a radio transmitter, AM, and it starts demodulating signals, and you can hear it, and it's tuning into AM radio. I don't know how else to explain it. It's not just frequency, making tones. No, this thing is like adjusting a shortwave radio knob and trying to hit the right frequency. So because the sound isn't that great right now, worked out right now, you're just going to see the effect. So I'm going to finally show you. So wet clay water in a glass tube. I put the clay in there because it's the only way to get a RAV created. And it's working as far as it's ionizing the clay in the water. You guys are so nice. Thank you. I can see the chat over here to the left. Appreciate it. You guys are wonderful. Now what's happening here, and you're going to see it in the next video, is that it's the plasma starting to compress, and it's starting to push itself into zones. Now you can see it break apart. Here it's breaking apart, and then it comes back. But these are going to start breaking apart to form a RAV. And you'll know when you got a RAV because it's super distinct. Now on the bottom, you see it starting to want to create, and there's so much sound to this. I mean, it is so incredible, the sound, as it's doing this. It is otherworldly. It's not what you would expect at all. All right, so it's working on ionizing the materials for the RAV, but it's not quite hot enough still. It needs a little bit more time. So this is the second video. And you'll notice now that the plasma is starting to break apart and bunch up. And as it bunches up, watch the bottom, and you'll notice what's going to happen is it's going to start compressing on the bottom. And watch what happens on the bottom. Look at that. It's just the plasma is just starting to push itself to the bottom And once it hits the bottom, boom, it's going to start turning this bright white, like a white light, like you don't really see naturally. It's starting to get there. It's getting there almost. Look at that. It's getting whiter. It's going to turn solid. There you go. It turned completely white. Now it's still now pinching. It's still feeding it. But look at how bright it's getting. Look at that white. It's starting to get brighter and brighter and brighter. And it's just incredible. It's just gobbling up the plasma. It's the only way I can say it. There it breaks apart, takes some more, and then it gets white. Look at that. It's so crazy cool. Now there's some other really cool stuff that this tube does, but I just figured this out today, so I don't have enough video. So we'll dig back into this creature because it's got some stuff going on. In my other videos, it actually starts forming fractal plasma geometries in the glass. And so bummer. Actually, you kind of see a little bit there. In the middle, you start seeing those crystalline structures start to form. And look at how bright it is. The whole bottom is white. It's pure white. I don't know if you can see it. Yeah, you can see it's pure white. And that hand of plasma, it just wants to touch it. And it turns white when it hits it. Yeah, there's a lot going on here because as the plasma streaks the glass, it streaks it in a fractal patterns. And so there's a lot to look into in this tube here. Again, just a glass tube, hollow tube, that's it, nothing fancy. A little clay powder and put it in water and then run it for 30,000 volts. That's it. Piece of cake, done. And you'll have this strange animal that I'm still trying to figure out. All right, we're gonna skip now because you guys got the hint. This is the microscopic look at lava rock. And what am I doing? Here we go. It's here. And then here is the, sorry about that. Sorry. So if you saw that the pre-lava rock, it just looks like a plain old lava rock with some kind of gray dust on it. And then after I run the RAV on it, this is a microscopic picture of the same spot. Now, it's not a great picture, but what you can see here is it's creating all these kinds of crystals. Okay, it starts off with yellow crystals, but then it starts really pushing out and growing white crystals. And so that you're getting the crystal. Now, all this is just where a RAV was running on top of a lava rock. Remember I told you lava rock was kind of a super RAV material where it created huge RAVs? Well, the remains of the RAV create this black glass, which if you dig into this black glass, it's very reminiscent of Mandelbrot sets. And then the crystals around it can look like stalactites, stalagmites, coral, and snowflakes. So we're getting a lot of different kinds of crystals, and we're getting this sort of Mandelbrot in the black glass here. So this is transmutation that was talked earlier about how it will take a molecule and just build it out. And I think that's what the RAV is doing here. It's just grabbing molecules and just building them out to its crystalline structures. Let's see, here's another one. You can see, look at all the crystals. It almost looks like salt crystals. But this is where the RAV was at. The RAV built these crystals, and they're not those wispy flying crystals that we saw. You can actually touch these and rub them on your fingers, and they are crystals. They're solids. So some of them are like a ash kind of feel to them. So they're not as structured as when you smash them or something. They kind of fall apart. But some of these are actually crystals. You actually feel them. Let's see here. So lava rock is a super RAV material. Look at how big these RAVs are. No water, just so lava is the super RAV material. I'm going a little long. I guess I should ask Nathan. Are you okay with me going a little bit longer? My hour's up. Nathan? Let's see here. Well, okay, we'll keep going. So, not only is this a super RAV material, the lava rock, but you'll notice how it refracts the light. Now, this is 4K, so the refraction of the light is super detailed. I really so Joe and Nathan have done an analysis on this light, on these light patterns, because when you get a prism and you break up the light and it comes out with certain colors, you can tell what materials are in that refraction. So there's some refraction going on here that you can get some details or insight inside the RAV. See, this is just another close up. Let's see. This is the more porous lava rock. Makes massive RAVs, very stable, last all day. Lava rocks are the super material. I scribbled some graphite on top of this lava rock. The graphite accelerates the plasma, and so you'll see that it creates multiple RAVs. What's interesting about the graphite is it accelerates the plasma and then shoots right through the rock. And right now you're not seeing it shoot through the rock. I've kind of not adjusted the voltage enough, but you can get the idea that how graphite works with lava rock to where it's just spinning out RAVs quite easily, multiple RAVs. This was kind of a fun little test. Charlie C recommended I put 2 rechargeable batteries next to a RAV. So here I did it for a whole hour. And what happened was both batteries increased in voltage by 10 millivolts. Now, if it was just one battery, I would just say maybe it's a fluke. But the fact that they both charged at the same rate and they're very different batteries, that was telling. And then my control batteries, yeah, no change. These changed. The RAV was the only deciding or different factor. So I'll run more experiments, but I thought that was interesting. And thank you, Charlie C. Now you can see the crystals over here to the right of the RAV. The RAV is just pushing out crystals. And I kind of wanted to show you how they look just from the human eye. They don't look like much here until you bring them under the magnifying glass. And so I'm letting this RAV go and just chew up and create crystals and move along and let the plasma do its thing. Look at how bright that is. And then I can analyze it later. So this is a nice clear picture. I was asked to put a compass next to it. Yeah, I mean, I do know that an electric field has a magnetic field, so it should move a compass, but hey, I thought I'd try it. So it definitely doesn't work at that angle. So I'm just going to change then the angle and make it perpendicular to the RAV. Right now it's parallel to the RAV. But perpendicular, we'll see. There we go. Yeah, it moves the needle. So yeah, we're definitely emanating a magnetic field. Pull it away, bring it in, pull it away, and you see that needle. Definitely a magnetic field that can be sensed. I have a Gauss meter, so I'll be doing some measurements, get you guys an idea of the magnetism that's going on around the RAV. These are the rocks I bought. You go on Amazon, you want the smallest rocks, 1/2 inch to 1 inch. They're tumbled. These are very cheap for 10 pounds. And all of these are all super RAV energy packets. So here, if you see that below, see what I'm doing here. I'm trying to get RAVs to form and then look at their wave patterns. So I'm trying all kinds of different things, and that's fun to do. You don't have to connect your oscope to anything. The oscope just has a little piece of wire here like an antenna. You can see it to the left, the lower left. It has a little piece of wire sticking out. So that's all you need. And then it's going to pick up what the RAV's doing. And it's really cool. Just leave your oscope probe right about 6 inches away, 5 inches. Look how close I'm bringing it. And you'll understand the different ways, different waves and frequencies that are going on inside the RAV. So this is me increasing the current and trying to make a RAV, and all it did is blow up my rock. So RAV is not a high current creature, and the RAV is not a high voltage creature. I put in 60,000 volts, got the same size RAV as 30,000 volts. Here I'm tripling, quadrupling the current from its 5 milliamps, and look, it just doesn't even know what to do. No RAV can form. Now, ooh, see, when it dropped to the 30,000 volts, 5 milliamps, you saw a RAV form. So what's happening here? So how do I do this? If you just put high voltage capacitors between your positive and negative leads of your high voltage power supply, then it's going to double, triple, quadruple your current. Now, I do not recommend you doing this unless you know what you're doing, because when you start adding capacitors, you start getting into these dangerous currents, and you don't want to get hurt. So you saw that the big heavy current did nothing. Take the current back down to 5 milliamps, and what do we got? We got a beautiful RAV. So the RAV is not a creature of voltage and current. The RAV is a creature of very, very defined environment. Let's see. I'm going too long here. Let me just get through. Here's the microscope that I use for the pictures. You can get them pretty cheap down Amazon. I think a really nice one's like 190 bucks. I know that's not cheap, but for what you get, but it's awesome. You just throw whatever you're doing under here. It's a 2000 times magnification. Let's see, we saw that. There's some crystals, more crystals. You can see that's the cathode wire, and you're kind of seeing them feathered out and kind of become like a turquoise color. Here now again, this looks like almost seaweed. The RAV created those structures. It's a little piece of clay, and it's covered with this. It's white when you see this in person. When the photograph is taken or the video, it turns this blue. So I don't understand that. It's some sort of pattern of the structures that changes the camera light. But this is all surrounded by these willowy crystals. This one interested me because these crystals here are forming on the bar, the metal, and you can see that they come up and then they come back down. This looks like the surface of the sun. I mean, get a picture of the surface of the sun where you see these things, solar flares coming out, and some solar flares come down and back because of the incredible magnetic field of the sun. This is fascinating because these are the crystals that were created by the RAV. Another shot of it, of those crystals, trying to get them focused because it's under a magnifying glass. You can see my cell phone trying to take a picture of it. Do you see how they move? They're like sea anemones or something, or seaweed. And the plasma created them. This is a really pretty shot. Plasma created all of this. This is just a little bar of wire, and then let the RAV run, and it organizes all of these crystalline structures. It's another picture. It has that blackish, weird glass in the middle, and you have the billowing crystals surrounding it. There's my device for the self-nucleating RAVs. Just a little piece of wire. So this is the last one, and we'll get to a close here, guys. When there's a very extremely thin steam, when it comes near the RAV charges it and it starts to become organized. So if you look at this, it looks like smoke, but it's actually steam. And thank you, Nathan. He pointed out that it's water vapor. But what happens is, as the water vapor comes up, it starts charging, and you come up with these designs. It may be better to see it that way. And the water just starts condensing and shooting around, and look what it does. This looks like it's photoshopped. look at the smoke, or look at the water vapor. I'm sorry. So this was the third kind of fractal phenomenon that's coming from the RAV. The RAV had the billowing crystals. It had the hard crystals on the lava, and now it's has this. Yeah, these aren't crystals. These are water droplets, but they start forming themselves into complex structures. Um, it's starting to get ready to form into another complex structure. So it sort of breaks apart. And look at this. It creates, let me see if I can do this. Yeah, here we go. And it creates this structure. So if I were to go frame by frame, the RAV is forming this water vapor, and you can see it to the right. That's it's a formation, I guess, an organized formation. No Photoshop, pretty incredible. Now we can go for hours talking about the RAV. So that's the wave pattern of the RAV, the angel RAV. You know, that piece of slag at the end of the wire where the RAV sits on, that's what it looks like. Has a flat face, and with caverns in it to keep the RAV cool. And this face right here always faces the RAV. So the RAV forms this, and then the RAV lives on this. Another picture of these are the caverns that Nathan predicted. He predicted them before me, so I'm mad at him. Again, here's a RAV on that self nucleating slag, or on the tip there. Let's see, another one, self nucleating RAV. You can see so I have quite a number of videos of these, too many, but I hope you're getting the idea. I can't wait to hear your questions. Just going to go through them. This is a nice shot of it. So I'm just pulling it away, and yet we still keep a RAV at the tip there, playing with the voltage. See another one. Boy, it's death by RAVs tonight. I think we're done here in a second. Yeah, I think we're done. Oh boy, I missed you guys. I have so much to share. Okay, let's see. This is kind of worth seeing here. You see the clay, and you start seeing the crystals form around it. Those crystals weren't there. The RAV created those. It's hard to focus. I don't know how to use my new camera. Just a typical setup. This is actually distilled water, so it actually has a unique effect. Because of the distilled water, it has less crystals, so it looks like the tap water helps in that crystal effect. Helps the RAV out in constructing those crystals. So we didn't get that. We don't get that cut all the way surrounded with those that fractal snow with distilled water. Just forms a RAV though. I mean, it works. It's just we don't get the as much of the fractals. Yeah, it's kind of a long video. Let's see. Oh, I do want to share this. So Nathan's putting a RAV in the middle of a Tesla coil, and he inspired me. He's always an inspiration. So I decided to put a RAV in as a primary coil, and the outside is the secondary coil of a Tesla coil. Just because Nathan's ideas are cool, and I had to steal this one. So here we have a RAV, and then on the outside we have coil 2 of the Tesla coil. Now, what I was looking for is that the RAV would resonate with this coil, and if you see where my arrow is, that little wire here, I should get a little plasma coming out because it should be oscillating, but it's not because I'm not matching the resonant frequency. But it was a quick and easy experiment. Nathan's going to match the resonant frequency of the coil and the RAV, so I expect it'll be awesome. But I tried. And so this is what it looked like. Here we have a RAV-powered Tesla coil with no sparks. I'm trying to get sparks there with the with a screwdriver. So it was cool. It was fun. And I think what I did too here is, oh yeah, so the Tesla coil secondary, the red wire here, it's about 500 turns of 34 gauge wire. With the RAV in the middle, I connect the oscope to the outer coil just to kind of see the waveform that's going on, because the RAV is interacting with this coil. And so if you can see, my oscope is going on the fritz. So this thing's transmitting something that's causing my oscope to go crazy. Doesn't normally do that. So I'm finally kind of zeroing in on the waves. And you can tell when the RAV's there or not there. The wave pattern still changes. So I got to feed a little water because it's clay, and trying to get a nice sweet RAV in there. There we go. You can see it get bright, and then you can kind of see the wave pattern in the background. But it was more just for trying to learn around the environment. I didn't really get anything big from the discovery other than, hey, how cool would it be to see a RAV in the middle of a coil and oscope it? So some interesting wave patterns. Definitely not the sawtooth that we're used to from the RAV. It's definitely that coil's doing something. And there's like a reflection or something because you're getting that doubling. So thought I'd share that. Okay, so which one are sunspots? One is the RAV spots and the other are sunspots. These are sunspots. But I thought it was fascinating because the RAV is like a little sun. All right, almost done, guys. Let's see. I have a whole nother presentation for you guys here, so I'll just skip through to the end. One more thing I want to share. Oh no, I passed it. I'm done. All right, so who knew lava was that magnetic? I didn't. So that's cool. It's got some metal properties in there. And that ends my presentation, guys. Thank you for listening. I appreciate it. Went a little too long. Let's see, Nathan? Let's see. Can you guys still see me? Uh-oh. Hello. I see you guys in the chat. Well, all right. Well, maybe we'll go back to what we were talking about. Let's see here. Pull it up. Let's see. We can go over some. I have plenty to go over. So here's an interesting thing about the RAV. What you can see here is that on my spectrograph, it shows this very sort of smooth slope. And when I've input this data into AI, AI basically said that this should not be the wave pattern, because this is a wave pattern of a very, very dense, very hot plasma. We're talking a black body plasmoid. And I don't even know what a black body plasmoid is, but it basically said that it's extremely dense. And then what AI said is, if you look over here on the left, how the blue is very low, basically what that means is that there's the electrons are not escaping the RAV. They're not getting out. The highest energy electrons are stuck deep inside the center. So that's what the small blue part here, it just shows means density of electrons, and they're not getting away. So you guys can see it here. All right, I hope Joe and Nathan are okay. So here's my new toy, the spectrograph. It was on a slow boat from China, so I had to wait. I had to wait months. Just hitting the button, and the light bulb that's lighting my room, that's the spectrum, the spectral lines to show you what basically is comprised of in the light. It gives you the full pattern, and so pretty cool. You can take this anywhere, and it'll tell you even in the dark. There's light going on in the dark, and I'm fascinated about how many. Yeah, guys, I hope Nathan's okay. Joe, I see you guys in the chat now. Yeah, I hope he's okay too. I guess I'll keep talking because I don't have the control. So let's see here. Hey, Joe, maybe you can call his cell. So this is an interesting material that I'm using. If you look at the bottom, there's kind of like a bowl shaped inside this stainless steel container. This little bowl part thing here is made out of pure pyrite. Now, pyrite's some interesting stuff, fool's gold. The interesting thing about pyrite is that I can build RAVs on it when I shouldn't be able to. What I'm saying is, if I tried to just put this straight on a piece of metal, this tiny piece of lava, the plasma would just run around it to the plate. But because pyrite is only semiconductive, it acts as like a giant resistor, and therefore it pushes all of the plasma currents back into this material here. And so you get this really nice big RAV out of this little speck of lava rock. And so that's interesting. I'm going to check out the comments while we present here. So I'll take a peek, guys. Let's see here. Let's see. Okay, I see Joe. I hope Nathan's okay. Well, I'll just continue, guys. I can check out the chat though if you guys want to ask questions. I can kind of do it. I'm looking at my iPad here, so and then we'll keep our ear open or eye open for Joe. Keep our ear out for Nathan. Let's see. Let's see here. This is the best ZVS circuit on the planet Earth. And if you build this circuit with copper pipe, then you will have an indestructible ZVS. This thing can do anything. Let's see, have you tried carbon fiber? No, I haven't. DJ Cosmo. I haven't tried carbon fiber, but I'll add it to it. It's a good idea. I'll just be taking notes for your questions and get you answers later. Let me know if you guys have any other questions. So this is the indestructible ZVS. I've searched the internet. I've built every ZVS. I bought every unique kind of ZVS, and this ZVS is it. It requires two power sources. One power source kickstarts the oscillation, and the second power source amplifies the oscillation into hundreds of volts. And then you pick off that oscillation with your primary coil, the Tesla coil, and boom, it then hits the secondary coil of the Tesla coil, and you get your plasma discharge. Let's see, John Bigham says carbon fiber with graphite coating. I'll write that down. It sounds interesting for what we're doing here. Thank you. Let's see. All right, graphite covered carbon. And so if this is a horrible way to screenshot it, I say reach out to Nathan because he has the real good copy of this print. And I highly recommend it for if you ever need an oscillator amplifier, if you want to high voltage. This is it. It lasts forever. It's durable. It's amazing. So with a little screen material, some metal tape, I created a Faraday cage. There's a lot of noise going on in this power supply, and it can mix with my measurements. So I created this little cage here, and then I ground it. And what's crazy is this power supply is so noisy. It has literally like 10 harmonics and noise coming from it that it can affect your test results. So I use this little cover here, grounded, and it just deadens all of the noise. So worked pretty well. Let's see here. Yanni says, yeah, I need to learn MOSFETs. Yeah, MOSFETs rule the world, man. So you have to learn MOSFETs. They're pretty simple. I mean, not much change from an NPN transistor to an NPN MOSFET. DJ Cosmos says it's like hair, strong only in one direction. Are you referring to the fractals? No. Are you referring to the crystals? That they're like a hair? Faraday shield. Yes. Thank you, John Bigham's Faraday cage. Yes. Thank you for that. Yanni struggles with transistors. I do too. I have a rule. If you have more than 10 components, I can't build it. I can barely build 5 component circuits. I'm not very good with building circuits. Yeah. So let's see. Prepreg carbon fiber. Yeah. All right. Oh, we see Nathan.
What's going on, man? This is letting you go for a little bit.
Yeah, I went to the end of the presentation, and then when I didn't see you, I started working my way back because I have 200 slides. So
sorry about that. I'm chasing this little kitten around my garage, man.
no.
Nathan, I tell you all the time that chasing pussy only gets you in trouble.
I was nervous, by the way. I was worried about you. I really was.
No, that was it. Dude, that was awesome, by the way, Shawn.
I was like, he better come back before Shawn gasses out. I was like, either that or it's going to be like, well, all right. Break that down next time.
Yeah. We got some good
sorry
questions.
about that.
Awesome work, Shawn, man. I thoroughly enjoyed that.
I appreciate that. Were you guys able to get a different kind of perspective or insight or maybe some clarity on what actually is going on? Not so much from what I said, but more in the clear video and the drilling in. Were you guys able to like, oh, that's how it's set up. Oh, that's what he's doing.
I mean, it's a lot more clear seeing, with you explaining it and stuff than just sending photos and videos and,
yeah, exactly.
trying to make heads or tails of it. That's for sure. But I think everything you showed here, I don't know that it brings anything new to the table, but what it does is it proves it out,
Yeah.
and that's what I was. We were kind of hyping some of this coming in between Nathan's presentation on Monday and then knowing you were going to come in at some point and show some of this stuff. Hyping it because this is not suggestive of transmutation. This is proof of transmutation.
Yep. You cannot deny the video evidence. I mean, you can't. Yeah, I mean, and it happens in different ways. So you know that it's a phenomenon that's not a one-time sort of lucky. No, it's everywhere.
Yeah, but even though it's done in different ways, it still occurs and shows itself in a way consistent with exactly how it works, with exactly what the physics behind it says.
sense.
And I think that's what's pretty awesome about it. The fact is, and one thing I think I did see that was new to me that I think was amazing to see was two things. One was with the ceramic tube. When it's configured that way, what it seems to be doing is actually breaking, changing, I should say, changing the interaction points. Okay. And when you change how the positive and the negative interact in that way,
Yeah.
and you make it rather than top and bottom, you make it sort of more inside and out, which is what that tube is doing. What you end up seeing is a phenomena that generally would exist intermedia, I would say most prominently. And that was, it seemed to be, you could see the field. You could actually see the movement that the field is creating.
Yeah.
Yeah, and it's not just heat. It's very, very apparent that it's not just heat rising.
Oh yeah. Yeah, there's
No.
something going on.
Let's check this out, guys. This is something Shawn was talking about earlier. Let's move closer to where he was. There's sound here. I upped the sound on it, and I got the zoom in. Yeah, watch your ears on this. It's pretty brutal. Okay, real quick, let me point out the top is moving up and down. That's where the sound's coming from right now. And when you see those splits coming in the bottom, you'll see it'll look like the beats come from the bottom.
Yeah.
Did you catch that at the end where the beats started popping in at the bottom?
But yeah.
It kind of looked like a ramjet.
I mean, it does. And, the way that it's all choking in the center, I mean, that probably has to do with all the ratios that we discuss all the time, too. And you can see you can see how it's beaded out on the bottom. You see that's all proportional.
Yeah.
I was telling Shawn it sounded like me like solar wind.
Mm-hmm.
You get the plasma, you get it whistling in the little cylinder, you know what I mean? You get a sound of solar wind.
It's
I thought it
hard
was
to
interesting. Good.
think
Yeah,
of
I mean,
it.
now the other thing that I never saw before was the color change that rapidly, and consistently. And that just goes to show that it was actually moving through those frequency bands as it changed. And then when it regulated, if you noticed, it shifted one way on the scale. And that tells you the direction your frequency was going. The frequency was increasing, which is why it made it into ultraviolet. And then, after it went purple, it went white. And that white is also paired with radiant energy at that point. Now you're falling into your radiation zones.
Makes sense.
Yep.
Makes sense. What'd you think of the RAV forming at the bottom and going super white, like the whitest of white, and it kept feeding it and compressing it at the bottom? I didn't expect that. The color change was it wasn't variations of oranges, yellows, and a little white. It was white.
Yeah. Well, it had to be at that point because it's past all the frequency bands to get to that point.
They're
So
all
now
once. which makes white light. Oh, yeah.
Well,
That
that
makes
and
sense.
you're going to get a hotter value because you're inside of a tube and there's nowhere for the heat to go. It's going to just go from yellow to white.
Yeah.
Now, when you did the sodium, but when you did the salt, by the way, and it was going yellow, that's again further proof of what's doing, because it had to break the sodium chloride into sodium to get the sodium to then reach the point of excitation where it would plasmatize and end up putting out the yellow light, which is known for sodium, right? And there's no way to get that glow without breaking that bond. So that you know that you've broken the bond, and to get the light, you're also breaking the sodium molecule, because it's the electrons that are ultimately doing that work at that point. It's interesting to think, because and that ties right into the fractal snow then, doesn't it? Because the whole nature of the fractal snow is that once you start stripping the valence electrons off of things, they can't hold into lattice bonds, and then you end up with atomic mass in a low energy state, and there's your separation. You get your accumulation right there. It's just part of the exchange that's occurring, and that is direct mechanism with what you were talking about before with the magnetic fields and being the mechanism of the spin, because you have the exchange, two-way exchange that's occurring between the energies, so giving and taking on both sides of it. And the RAV is just what's is storing, compressing the energy side of things. Whereas the other side is just structuring out the atomic mass, because the atomic mass is a greater density potential. A lower volume but higher density potential.
Makes sense.
Nice.
So that would be like an instance of that would be the RAV on the lava rock, where the low energy what is it, matter, I guess, is deposited or created by the plasma on the lava rock, those crystals. Is that what you're referring to? This is a low energy state?
Well, right. So, I mean, it's been the theory all along that the anode side wants the electrons, and that the anode side is going to take the electrons from the densest place that it can, but that's also free and available. So it'll take free and available ones before it'll take the more dense ones, but once it finds the more dense ones, it goes after that too, and they'll fight at nothing to get it. That's how it ends up burrowing in, and creating that. But at the same time, it's also burning up atmosphere, just ambient atmospheric gas, and bringing that into the equation to keep it going in the interim. That's sort of my idea on it, at least at this point. It also explains a lot about why Nathan, when he was running the tests the way that he did, without a cathode and then 2-on-1 and then moving it off and stuff, why that was self-sufficing. But we just got to remember that, again, what it's feeding off of is, it's significant in terms of what you could potentially get out of the other end. Because you want to be able to have as much free electrons as possible, in order for it to reaccumulate. You said that your main goal at this point was to get it to not feed off of and not be attached to anything, just float and do its thing.
Yeah,
It's my
that
opinion.
and water. And in water. I want to get it working in water.
Yeah. So on that note, it's kind of my opinion that to do that, you would need to create a saturated resonant environment in which it can then operate, because without that, I don't think it can. So it need, you would need a saturated resonant environment. The same as when we were talking about the Graviflyer in the context of it, right? You can't have it escaping. It needs to be in that resonant environment, or it needs a power source. One or the other.
Okay. So before we went on air, Shawn and I were talking, and I told him, take your anode and cathode, put them together, get your high voltage hiss, and you can see the stuff moving from one side to the other, right? So you have a permanent environment, and then now add sound in a rotational way, or you want magnetism, whichever one you think is going to do the curl, um, and then try to get it. But then it's only going to be there for a few seconds and then go away because we don't have the voltage to pull it off long term. Because it'll go self sustain and then top out. You know what I
Yeah,
mean?
yeah, it's
There's
not a
not high
closed loop
enough.
system in that without the compression factor, going on. And the thing is, so like what Nathan was saying about building it into in the middle of a secondary coil,
Mhm.
well, that'll throw it into resonance, and then it'll be in a resonant environment. And as you know, the coil brings out longer than the power is on. But how long additional is that going to add to be able to sustain the RAV? And in
Mhm.
a free float environment, chances are more than none, but not enough to be significant. So
Mhm.
the key then would be monitoring the resonant frequency of the RAV itself,
Yeah.
and then having that self-modulate with something powering a coil, okay,
Mhm.
like real time, so to speak. And that way, when you take it away after it's formed, now it's in a permanent resonant environment. It's still powered by something at that point.
Right.
It's not
Right.
powered in the traditional sense, but it's stabilized because it's in the resonant field. And then it would probably go up and down and zip through the wall of it and do whatever it's going to do. It depends on what your magnetic field of that coil looked like, right? Because if you got it in the center of the coil where the null zone is, right, or whatever, then you probably have a shot at keeping it somewhat there. As soon as it's out of that null zone, it's going to want to find its way into like the most stable spot.
Yeah, but
Yeah.
okay. So if you wanted an open air, you'd have to flow the plasma to do it. I would say this: if you're looking to sustain it in the perfect center of it,
Mhm.
take your speakers and run them in a circular pattern like this. Take another one here, and you basically create the shape of what we know as an atom. And in the center of it is where it's going to hold it because the speaker is all direct in an ultrasonic pattern, and it'll hold it in the center core. If that's what you were looking to do, but open air just to create something that's like a ball lightning, then you would need a free flow from anode to cathode. But with the hiss, so you can see the purple plasma, then you need the sound right there or the magnetism to spin it and keep it.
Uh-huh.
But I don't know that it's going to hold it forever. Is what I'm saying. I think it'll
So,
be
so
a high
Yeah.
you
speed
read my
camera
mind
thing.
with this, Nathan, and that was my thought when he said it too. And that's why I brought the field into the
Hmm.
equation, because the only way to get it without the field would be to use your ambient field, which means that you would need to have a RAV that falls perfectly in sync with both our atmosphere and the Earth, and fall properly in ratio as to it. You know what I mean? In
Yeah, yeah,
order for it to then, because then actually it could run off of that,
yeah,
but
yeah.
it's got to be built
Yeah.
that way.
I wasn't saying it to be stable. I was saying it like a lightning bolt. It leaves and
Hmm.
travels and dissipates. I wasn't thinking it's something that is like a, you know what I mean, self-sustaining, um, you
Right,
know what I
right.
mean, existing
High speed
in,
camera is what you would need. Something to just slow it down a little bit.
Well, you're
yeah,
already kind of getting that. You're getting bits and pieces of it, because if you look
true.
at these things in very slow motion, which is what I do, and you
Yeah.
Oh yeah.
zoom in and you take it frame by frame, you notice bits of compressed plasma flying off of this thing, all like not all
Good
the
point.
time, but in certain circumstances.
We were
Yeah.
looking at that
Great,
earlier today. Yeah.
Yeah,
great.
so you're already taking bits of RAV and throwing it in a stable manner
Well,
outside of the
let me
area that it was
just
Very
created.
good point.
let me
Very good
just
point.
say this, okay? Because I think you guys need to understand it, kind of like I do. When this thing goes out in spheres, what it's actually doing is like the plasma inside the tube. It'll go in that layer of the sphere and it'll spin like this, okay? And as it does
Mm.
that, you get very high frequency sound, okay? But you're also getting the boundary layers, which is the frequency, okay, and the magnetism within that. But then you take that to the earth and you look at it and you go, okay, you have each one of those like this, but an anode cathode effect. So when you get storms going on, it brings it down to the layer of the cloud. So now this zone right here is your purple zone between the anode and the cathode, where you can hear the high voltage hiss and everything, where normally it's up here, it's too far away. Okay, but you brought it down here in weather patterns. Okay, that's the point. Now you have that in there, so all you do need to do is replicate that sound and that magnetism that's going on there in order to get the ball lightning to achieve itself. You just have to think of it the way the Earth does it, then redo it in
Makes
the lab.
sense.
Yeah,
Makes
I agree with you 100%. That what you're just saying right there was that exactly the same exact reason that I was saying to enclose the gravifier and get the materials right, because it's forcing the compression at that point. And that's why you can hear and see literally the frequency change and quickly and linear in a very linear and logical way, right?
Yes.
You can hear the pitch going up, you can see the light changing color, it's working. And as you know, how do you measure the speed of the rotational force of the RAV? Because we know that that's directly related to the compression. Well, you do it by measuring the frequency bands. That's how you did it, right? So you know that when it's increasing in the frequency, it's increasing in the compression. It's also increasing in its speed. Now, I don't know what the speed would be, but I would gather that you get it to spin fast enough. Okay, at that point, it's still laws of physics. You put anything into that type of motion in that state of compression in a high density state, it's going to keep going like that for a little bit. Like that's just, it's got
like
that momentum.
spinning it faster, and so it'll spin longer. That's a great analogy, and it's an analogy that directly relates to what you're saying. Get that thing spinning a million hertz, and boom, it can have some sort of momentum. John Bigham puts in the comments, though, that he thinks that they can be self-sustaining. I'm just checking them out while we're talking.
Well, I would agree, but I don't know that they're going to stay forever. And that's the thing we see even with ball lightning. It'll dissipate over time. It has to do with how much compression and how much energy you put in the compression and how much time it takes for it to fade away.
Yeah.
But I don't think they'll stay forever.
Yeah, I think that that's highly dependent on the environment in which it's created. The more stable the environment with the less fluctuation of any given factor, okay, would immediately place that in a situation where it's going to last much longer, if not indefinitely, under those circumstances.
Oh, if you keep
But
feeding it with the environment,
But now follow what I'm saying.
Yeah.
But it's actually changing its immediate environment too, right? So it's just about pushing it further past whatever threshold that is to fully break the locality of it. You see, because that's what makes it then superconductive. Once it's superconductive, okay, it has its own environment that is stable, and then it can self-sustain. But it's whatever that threshold is of the difference between it and the environment.
Okay,
The interesting question, though, is what happens to the other side of the RAV when it hits that stabilization? Because I propose that it actually collapses and combines when that happens.
So if you look at the RAV that had the 0.16 millimeter wire and it's balancing on that, you get a pretty much almost 360-degree view of the RAV. So when you're talking about the bottom of the RAV, are you talking about the inside of the RAV, or are you talking about the actual bottom of it?
In what context? I'm sorry, I don't know.
Yeah, you had mentioned that you're seeing the RAV. Forgive me, I am very having a tough time. You mentioned that something about this is what is going on the outside of the RAV or top of the RAV. But then you said something
Okay, pardon me. Okay, so what I was saying below it. Well, okay, no, I got you now. So to clarify, what I mean is we obviously know that what's going on is inverse on the cathode side. It's what we see. It's what the theory said before we said anything.
Yeah.
what I was saying is we know that that's going on below. Now, what I've proposed in the past, right, is that when you have the breakdown of the molecule down to the molecular level, like a compound to a molecule, and that or broken off a lattice, one or the other, right? Same thing
Right.
mostly. Then you have that breakdown into its electrons and its atomic mass. You have them separate. Okay, so now you have this high energy state, low energy state separate of each other. It's what it's doing. Now, what I'm proposing is that once you cross the threshold, when you break locality, that those sides actually reculminate, okay,
Okay.
into, and that would be the fusion event, by the way. It'd be clear, okay? So the low energy nuclear reaction that we're currently having, okay, is less, I'm not saying it's not transmutive, okay, at all. But
Sounds
what
like
I'm saying is that the transmutation that's occurring is occurring intramedia through the exchange. Okay, whereas if you actually cross this threshold, you'd bring your atomic mass side in to combine with the high energy side, which is their original state. And then whatever resonance that they have is a beat frequency between the two. Okay, the offset differential, right, would be deterministic of their structuring into new matter. Does that make sense?
Yeah.
Whatever that threshold is, it would also break locality and become self-sustaining at that point, act as a vacuum in a pump, and just start accumulating is what it would do.
And could you relate what you just said to actually what we're seeing with the crystalline?
Absolutely. So when you hear the pitch go up and you see the colors change and you see the structuring on one side and the RAV on the other, if you were to push it further past an unknown threshold that I believe to exist, okay?
Mm-hmm.
Once you pass that threshold, I would believe that the compression of both sides would become so much that the magnetic fields and how they're interacting, rather than work like a figure eight, okay, they would actually combine, and it would then create upper dimensionality again. Because remember, this is all energy vectoring, okay?
Okay.
Oh, Joe froze.
I was gonna say pause.
Static. Yeah.
Sorry, Joe.
You haven't frozen yet, Joe?
Whatever.
You froze.
You
We're,
froze.
we're making poses because you froze.
So anyway, it all has to do with energy vectoring, right? So if you and energy vectoring and dimensionality are directly in relationship with one another. So what you start to understand is that static is one dimension and then current is two. Then when you take two dimensions and you bring it into a magnetic component, it becomes three, then four. When you bring them all together, they're all each individual bit plus the sum of all, right? But they don't ever cross over that fourth dimension. Now, when you take these things and then they're split and then you bring them back together, you've actually taken it and put it to the power of two. Okay. So once you put it to the power of two, all of a sudden your mass reaccumulates. You have new time variations that would be involved, because, and this is different than the ambient environment, because the ambient environment around it is, we'll call it three-dimensional, subject to the fourth. Okay. But this would be to the fourth square, to the second power. So because it's made in this dimension, but then it's split apart and recombined, it then goes up in orders of magnitude. So you're dealing with higher dimensionality. What that means is that you have a separate time situation, you have a separate gravity situation, you have a separate mass and density situation. That's what I theorize. This is on the fly. It's just what I'm thinking. I don't know.
No,
Hold on. You do realize when you're talking about the sphere of the Earth and stuff like that, for every layer of energy that you put in there, it has a time dilation field. The time dilation field is directly related to the frequency because it's F equals 1 over T. So every layer has its own time. And the further distance you get from the center layer to the outer layer, the time changes. That's why you'd have to redo all your satellites in order to get GPS to work.
That's
It's
right.
in physics. It's all in there, and you're right. But you got to remember when you're talking about the different time and stuff like that, it's because each layer has a different frequency. So when Sean builds out 94 kilohertz over to 98 kilohertz over to what was it, 102 kilohertz, those are his three frequencies he came up with. Every one of them has its own time dilation field inside of it based on F equals 1 over T. So that's absolutely perfect in physics the way it works out.
Yeah.
Mhm.
But that's why each layer that you go up in the earth has a different frequency because they're built out that way. But
Yeah.
that's the anode and cathode effect in the RAV. It's perfect planetary physics.
Right. So we keep on saying this over and over again for almost 2 years now, a year and a half, whatever. Break locality. But what does that mean? Well, it's really, you could describe what the effect of breaking locality would be, but how to do it has been a little elusive to put into words. But this is now built up to the point where we're able to now articulate what that means. It means that okay, it's broken. We've broken it down, right?
Okay.
You could see it. You could now see it start to build back up. And then you have to bear in mind where you are in the relationship of where you are and what it's doing versus what you're doing right here in this closed system, right? And once that occurs and you break it apart, separate it, have it work together in an exchange, but then recombine it, now you have the fusion event. That fusion event is not subject to the same reality that we're sitting in right now. And that's not.
Yeah, I think fusion breaks quantum mechanics because it's the quantum tunneling for hydrogen atoms to become helium. So is that what you're talking about when it breaks?
Well,
gravity?
yeah, that's like a more controlled and unusual state. This is more dynamic than that.
Yeah.
Because it's not a chemical reaction. It is a chemical reaction, but the quantum tunneling factor of it, you're already seeing that. How do you think the electron gets through your ceramic that's non-conductive? Well, the fact is that nothing is non-conductive until it is, right? So whenever you put something past a certain threshold, we refer to it as an insulator because under common use it is. But this is no longer common use because you're taking super high energy potentials
Yeah.
and you're compressing them, and then you're putting them into into direct contact with it. That ceramic is as good as a conductor to that energy state. Nothing is totally immune to conductivity. It's just under normal use. So that's really what you're looking at in that situation. Pretty
That's
crazy.
said. It's well said. I just needed the ceramic to conduct for my experiment. And I couldn't until I added water. And then when I got it conducting, good. Cool. Now I can actually run my experiment. But you're bringing me back to actually what it's doing.
Yeah, right. Sean, why did it not until you added water? Because you knew to add water, but why not? Because I know why.
I knew water would be the in-between conductor to facilitate the friction that the